Okay, let's look at trying to solve different types of equations. Equations that involve rational expressions. So maybe something sort of simple looking. We'll just put x's here, here, and here. So x divided by x equals x. This is a rational expression on the left because this is a polynomial divided by a polynomial. Might not look like a polynomial, but x is a degree 1 polynomial, and x is still a degree 1 polynomial. So if I take a degree 1 polynomial divided by a degree 1 polynomial, I can divide and get a rational expression. It's still a polynomial divided by a polynomial. And over here, I just have x, which is my variable. So how might I try to solve this? Well, let's think about it. One thing I could do is I could multiply both sides by x and get this. At this point, I can then factor, and I get two solutions. Or do I? Go back to what we were originally trying to solve. This makes perfect sense. 1 over 1 equals 1. But this does not. What's going on in the case where x equals 0? This original expression, it's not even defined. And I'm doing some sort of a weird thing where I multiply by x, which is multiplying both sides of an equation by 0. Is it ever a good idea to multiply both sides of an equation by 0? Like, let's say I start off with some ridiculous falsehood, and I multiply both sides by 0. Hey, I turned it into an equation which is always true. So, not something I want to do, multiplying both sides of an equation by 0 in order to get anywhere. But let's try to actually understand what's going on in this. So, if I have an equation like this, I don't have to go back when I'm done and test out every solution in order to see whether or not it actually works in the original equation. Why is that? Well, let's look. I can add 1 to both sides. I can multiply both sides by 1/2. And I know that if this is true, then this is true. And if this is true, then this is true. But these steps both go in both directions. If I wanted to multiply both sides by 2, I'd be fine getting to here. And if I wanted to subtract 1 from both sides, I could get to here as well. So I could go back and forth between these all day, each one using just legal moves. So what was going on if I say, have this equation and turn it into what we got before? Okay, so let's think about it. If this is true, then this is true. But if this is true, this is not the case. Not every solution to this is going to be a solution to this. Not every one of these steps is reversible. Why is that? Well, we multiplied by an expression that involved a variable. And whenever you multiply by an expression that involves a variable, there are going to be some issues that come up whenever that expression could be 0. And sometimes there might be more than one number for which the expression is 0. If I multiply both sides by x, it's pretty clear when x is 0. But I could have started off with an equation like this, where it still might be kind of clear where this is 0, but maybe not. I could do other things to obscure the points where the expression I'm multiplying to both sides is 0. So what am I going to have to do? Okay, I'm going to have to be very careful whenever I multiply both sides by an expression with a variable. Multiplying both sides by an expression involving the variable. Whenever I do this, I have to be careful and I have to check each solution in the original equation. So, for example, if I have a situation like this, where I might be, hey, multiplying both sides by a half, I don't have to worry. But if I have a situation where I'm multiplying both sides of the equation by x, then once I'm done, each solution I get, I want to make sure it makes sense and fits the original equation that I was asked to solve. We'll do some more involved examples next.